Hello everyone, welcome to Heritage Great Architecture. This is Architect Chanda Sinha, your educator, and today I'll be discussing with the section 3 topic, that is the environment planning and design, and it comprises of 2 to 3 questions in GATE paper, and you can expect like 1 mark questions from it. Okay, now it is one of the very easy topic, and yes, before that, let me tell you that urban planning part 3 lecture will come after this lecture, because I recorded that one, but due to some sound problem, I have to re-record it. Okay, so just have a bit of patience for 1 or 2 days, and by the time let's see this. Okay. So now let's start with the first topic of this section, that is the ecosystem. Okay. Ecosystem. So what is ecosystem? So it is a type of system where there is biotic and abiotic component. Okay, and there is an interaction between them. Okay, so it comprises of both biotic and abiotic factors, and there is an interaction between these two. And the branch of biology which deals with the study of this biotic and abiotic factors and the interaction between them is known as ecology. Okay, so ecology means the study of uh, biotic and abiotic factors and the interaction between them, and ecosystem is the unit of this ecology, that is the basic unit of ecology. Okay, so after this, let's read about the natural ecosystem and the artificial ecosystem. Okay, so natural ecosystem. Okay, if we talk about the natural ecosystem, it can be further divided into terrestrial and aquatic. Okay, terrestrial ecosystem and aquatic ecosystem. So when we talk about the terrestrial, means the ecosystem which exists on the land. Okay, so like it can be further divided into like grasslands. Okay, then forest, then desert ecosystem. Okay, now if we talk about the aquatic ecosystem, again it is of two type. First is the fresh water. Now if there is fresh water, then there will be different type of ecosystem, and when there is marine ecosystem. Okay, like what is the example of fresh water? Your lakes, streams, rivers. Okay, and when we talk about the marine ecosystem, it is what? Oceans, sea. Okay, so this was all about your natural ecosystem. Okay, now the artificial ecosystem is also known as man-made ecosystem. So let's write that, man-made ecosystem. So this is also known as artificial ecosystem. So again it is divided into terrestrial and aquatic. Okay, so terrestrial, what can be the example of terrestrial? Like the crop fields, the agriculture fields in a very vast area. So that is your terrestrial. So I'm writing it here, crop field. Okay, now if I talk about the aquatic ecosystem, aquatic artificial ecosystem, so that will be your what? Like aquarium. Okay, so we are artificially trying to make an ecosystem in our built up space. Okay, now let's see. Basically, what happens, that suppose this is the you say terrestrial. I'm telling you here with an example. Like this is the terrestrial ecosystem. In this, what happened? There are man, there are animals. Okay, then we have abiotic. So these are you have plants. Okay, you have trees, then air is there, sunlight is there. So okay, so not only the biotic factors are interacting among themselves, but they are interacting among the abiotic factors like air. They are breathing air, they are taking sunlight as a source of energy. So not only they are interacting among themselves, but they are interacting with the abiotic factor also, and thus this comprises your ecosystem. So this is the terrestrial, which is taking on the land, and the aquatic, which takes place in the water. Like if we see the aquatic ecosystem, then we have aquatic plants, you know then we have fishes. Okay, then we have different type of water organisms. Okay, now they are living in the water, that is the abiotic factor. They are using sunlight, they are taking oxygen. Okay, so living organism, abiotic factors, interaction among them. So an ecosystem. Okay, so this was basic about this. Now let's read the next. That is your first we will read about the biotic components. Okay. So what does this biotic components comprise of? So it basically includes, okay, biotic components. Now these are very easy topic, like you must have read in your lower classes also, like um, producers, consumers, decomposers. So it comprises of producers, that is plants, then consumers, that is we animals. Okay, and then decomposers, which feed on the dead and decaying matter. Okay, so producer here is the plant, to whom we call as autotroph also, and then we have consumers. Okay, consumers like we animals like herbivores, carnivores. Okay, so these are your consumers. And next is your decomposers, that which feed on the dead and decaying matter. Okay, dead and decaying matter. So basically these are your fungi. Okay, then you have like detrivores. What are detrivores? Like your earthworm and vultures. Okay, yeah. Now these are some basic things which you should know. Now this was asked in, like, what is the biotic component? This question was asked in GATE, means related to this topic, GATE 2013, then 2006, and even in DDA 2019. Means related to this topic the question was asked. Now you can see how easy the question can be from this particular topic. Now after this, let's read in detail about the producer first. So what are producers? As I told you, the one which are producing food from themselves, and they are known as autotroph. Auto means self, so they are producing food through photosynthesis, and they are not dependent on anyone. Okay, so they are known as producers. Okay, so all the green plants will come uh, in this category. Okay, means they are producing their food uh, through sunlight, through photosynthesis. And next we have is the consumer, and consumer is known as heterotroph also. means they are dependent on the autotroph for food, because they cannot synthesize their food on their own. Okay, so they are dependent on the producers, that is the autotrophs, for food. Now it can be further classified into primary consumer, secondary consumer, and tertiary consumer, and so on. Now when I say primary consumer, means which are directly eating the plants. So this is known as herbivores. Okay. Then we have secondary consumers, means the one who is eating the herbivores. Like herbivores ka example you can take like any cow, rabbit. Okay, fine. Now secondary consumer, that is the one who is eating herbivore animals, so they are known as carnivores. Okay, then we have top carnivores. Okay, so this was basically your consumer. Now come to the next one, that is the decomposers. Okay, so what is decomposers? The one who is feeding on the dead and decaying matter. Okay, okay, yeah, I wrote it earlier only. And what are the abiotic components like air, water, sunlight? Clear? Next we have what is the function of ecosystem. Okay, what is the function of ecosystem? Now this can be asked. So basically two things. First is your nutrient cycling. Okay, nutrient cycling. And the second one is your energy flow. Means flow of energy from one trophic level to the other, like from the producer to herbivore, then okay, from producer to consumer, and from consumer again to decomposer, then to soil, and from soil again to producer. Okay, so these two are the basic thing. Now nutrient cycling means whatever the organic product is made, like suppose this is the plant. Okay, herbivore will feed on it, then it will go to consumer, then again the consumer will you know, it will be it will die one or the other day. After that, suppose this is the dead and decaying material, the fungi and bacteria will come and it will degrade this dead and decaying matter, and again the organic substances which was there, it will again turned into inorganic substances, and after that it will again go to the soil, and through soil again this plant will consume all the nutrients, and again the cycle goes on. So nutrient cycling. Okay, and the energy flow, that from producer to consumer, and from consumer to decomposer. Okay, so this is the function of ecosystem. Now next we have food chain and food web. Okay, now when I say food chain, what is food chain? Food chain. Okay, so it is the process of eating and being eaten in a successive trophic level. Okay, like you know, plants are being eaten by goats, goats are being eaten by your lion. Okay, so eating and being eaten process is known as food chain. Eating and being eaten. Now these are some basic things which I think you all know, but these things are included in the syllabus, so I have to deal with this topic. Now, yeah. Now, from food chain, what we see that I told you there is an energy flow. So let's make an energy pyramid here. Energy pyramid. Now, what is energy pyramid? That one rule which you should know, that whenever there is an energy flow, it is always in unidirectional. Okay, like there is no two-way flow of energy, always in the one way. Like suppose this is the producer. Okay, suppose this is a plant. Okay, now it will be eaten by any herbivores. Okay, now consumer, any carnivore will eat the herbivore, and this will be eaten by decomposed by decomposer. So what will happen, that whatever the energy was there in the with the producer, it will pass on to here, but it never happens that the energy will go in the reverse direction, always in this direction. Means this is the source of energy, some energy will pass on to this, some will then again this. And now what is that some energy? That is 10% energy. Suppose it had like 1 lakh joule of energy, then the 10% of it will be passed on to herbivores, like 10,000 joule. Again the 10% of it will pass on here, and again 10% to it pass on will be passed on here. So energy pyramid is always upright, because see, this was suppose 1 lakh joule. Now in the next one we have 10,000, so it will be quite lesser than the bottom one. Then again the upper trophic level will be even lesser than the below one. So this is the upright. You can see bottom, then up, then up. So this type of pyramid is known as upright. So this is the energy pyramid. In the upright direction, unidirectional flow of energy, and always 10% energy is passed on to the successive trophic level. Is that clear? Yes. Okay. Now what is food web? So multiple food chains when are interlinked with each other, then this is known as food web. Okay, easy. Okay, now let's start with the next topic, that is the definitions. So first we are going to start with ecotone. Now it has been asked multiple times, like in GATE recently 2019, then in 94, and even in ISRO also, ISRO 2020. Now what is ecotone? So ecotone is basically the boundary between two ecosystem. Okay, now let me explain here with the help of an example. Like this is the aquatic ecosystem, and suppose there is a, now these are the small shrubs. Okay, and this is the land area. So this is the terrestrial ecosystem, and this one is the aquatic one. Okay, and see, this is the transition area. This is the transition area where two different type of ecosystem are coming in contact. Okay, so this type of ecosystem is known as ecotone. Okay, so this was all about ecotone. Now come to the next one, that is homeostasis. Now what is homeostasis? So basically we can say that it is a state of equilibrium in an ecosystem despite of all the disturbance which are created. So let's take an example of a human being. Okay, on the individual basis also, like suppose there is too much of heating, then we sweat just to maintain our constant body temperature of 37 degrees Celsius. Suppose there is too much of heat outside, so in order to maintain our internal temperature of 37 degrees Celsius, we tend to sweat a lot. Okay, so to manage the heat outside. So similarly, we are also maintaining a set of a state of equilibrium. Okay, in the same way, our ecosystem also maintains an equilibrium or the sense of stability despite of all the environmental disturbances. Okay, so homeostasis. So this was there in the option of GATE 2013. So in ecology, it is the ability, it is defined as the ability of an ecosystem to maintain its overall overall stability despite of all the disturbances. Okay, clear. Now suppose let's take an example. Suppose it's a aquatic ecosystem. Okay, so there are zooplanktons and phytoplanktons. Now what is phytoplankton? So these are microscopic plants, and zooplankton, that is the microscopic animals. Okay, now suppose these are your zooplanktons. Okay, and these are your phytoplanktons. Okay, now initially what happened, that the phytoplanktons was more in number, so zooplanktons was less in number, so they started feeding on this phytoplankton. Slowly what happened, the number of phytoplankton decreased and the zooplankton increased. Okay, now what will happen, that there is a we can see here that the stability is not created, stability is not maintained here, like the phytoplankton is less in number and the zooplankton is more in number. So what will happen after some time, that the how nature will try to maintain this, that since the phytoplankton is less in number and zooplankton is more in number, so there will be less of food available for them. So what will happen, they will starve and they'll die. So again, after some time, the zooplankton number will be decreased and the phytoplankton will again start to increase their number. So we can see that an equilibrium can be maintained. Sometimes its number is high, sometimes this number is high, but overall we can see a sense of a stability is there. So this is known as stability in an ecosystem. But if we see the that homeostasis, it is on the individual basis also. Like I told you, we regulate our body temperature, whenever there is winter and our body temperature goes down, so we start to shiver in order to maintain our body heat. And whenever there is summer, we tend to sweat a lot just in order to keep ourselves cool. And so at individual level also we are maintaining homeostasis, and on a broad scale also, like ecosystem, we are maintaining the equilibrium, that is the homeostasis. Okay, I hope it's clear. Okay. Now come to the next one, that is your habitat and niche. Okay. Now what is habitat? You must have heard about this word. So it's the address. Okay. It's the location where a particular organism is found. Okay. And now what is niche? So niche is a professional address of any organism. Like suppose an organism is found in a particular area, but what is its role in that particular area? That its professional address is known as its niche. Okay. So first let's write the definition of habitat, that is the address of an organism, that where a particular organism is found. Next is your niche. So it is the professional address. Okay. Now suppose this is the area where a particular organism is found, and what is its role to the environment, what is its role in that particular environment, in that particular ecosystem, is its niche. So we can say it's the professional address of an organism. Let's take a very simple example. Like suppose a professor is found in any college. So that college is its habitat, and the niche that he is a professor over there. So that is its professional one, and he will be found in the architecture department. So that will be his niche. Okay, clear? Okay. Now come to the next one, that is entropy. Again, it was there in one of the option of GATE question that okay, let me tell you what is entropy. You must have heard about entropy in chemistry, that the degree of disorderness, okay, or the degree of randomness. Degree of randomness is called as entropy. It is indicated in or represented by delta S. Okay. Now, whenever we see or whenever there is any ecosystem, so it is generally, it is generally believed, or it is generally thought that it should be in a stable condition. Okay, whenever there is a stability, so it means whenever the stability is high, so the randomness is low. Okay, randomness is low. So it means that for any stable ecosystem, the entropy should be very low. Okay, the entropy should be low. Okay. Now come to the next one. Okay, this was there in option GATE 2013. Now come to the next one, that is ecological succession. You will get this term again in one of the option of GATE. Ecological succession. So let me first write the definition, and then I'm going to explain it. So it is the gradual process of change and replacement of all types of species in an ecosystem. in an ecosystem. Okay. Now let me explain you with an example here. That suppose there was a barren land. Okay. There was just a barren land and there were rocks in that, no life form. Okay, no biotic factor was available there. So what will happen after some time, we will see that a few lichens like algae and fungi, or few algae, bryophytes, they will come and they'll start invading this bare rock. Okay, so there was no life earlier, there was a barren land and few algae or lichens, they started to come and they invade this rocks. So what will happen, we will see that there will be the weathering of this rock and the soil will be formed here. Okay, soil will be formed, then this soil will support the growth of plants. Okay, so from no life to the life form, there we can see a proper succession. So this is known as primary succession. Okay, this is the primary succession. When we move from no life form to life supporting factors, then there is called as primary succession. Okay, but suppose due to flood or earthquake or any natural calamity, this whole biotic factor gets destroyed. Okay, suppose there is too much of flood, then after some time again, when there we see life form is again available there, then that is called as secondary succession. Okay, now suppose there was too much of flood here, then after some time again, because the soil was available, even though some of the soil it flowed away, but still some of the soil was there, life existed earlier, so again some plants will start to grow. So this is called as secondary succession. So primary succession, secondary succession, and we can see that different form of life, different type of species and life form are being supported here. Like पहले lichens आया, फिर we see different type of bryophytes, then we see different type of plants. So we can see then again some animals will come. Okay, so this is all about the ecological succession, that how due to certain gradual changes, different life forms are being supported. Okay, okay, this was all about the ecological succession. Now come to the next one, that is your hierarchy of this biome and biosphere and everything. So I'm writing the hierarchy. See, like it starts from an individual. Okay, and that individual you can say like species. Okay, a particular species. Now this species will now the group of species is called as population. Okay, group of same species, like similar species, what we say, group of same species. It means that suppose if we are taking human beings, so the group of human beings will be called as population. Similarly, for cat also there will be different population of cat, for human being different population of human being, and different population of your dogs. Okay, so for population we count the same species. Okay, then what happens, that group of population, now we will take everything in account. Now, cats, dogs, humans, plants, everything. So the group of population is known as community. Okay? Group of population is known as community. Now, whenever this type of communities they form, so they tend to form on a larger scale, is the ecosystem. Clear? Now the ecosystem, now when there is several ecosystems like aquatic, terrestrial, okay, so they form biomes. Okay, group of ecosystem is known as biomes, and group of large biomes is known as biosphere. Biosphere. Okay. Now related to this, one question was asked in ISRO 2019. Clear? Okay. So species, population, community, ecosystem, biomes and biosphere, right? Now come to the next one, that is your carrying capacity. Carrying capacity. What is carrying capacity? That the number of population which is supported by a particular land, okay, on earth, that is known as carrying capacity. Yeah, number of population or number of individual, also we can say number of individual which is supported in an area. Okay, now suppose this area, it has a limit of 100, let's say 100 people. So its potential is to support the support the system of 100 people. But suppose it will start increasing its number to like 200, so it is going more than that, right? So will it support this much of population here? No, because we have limited number of limited resource, limited land, so of course it will not support. So every land has a particular carrying capacity in terms of resources. So let's draw a graph here to understand it very well. Yeah. Now I'm taking two cases here. When we have limited resources, like we have limited number of land, limited food, okay, and when there is plenty of resources, okay, so there is no limitation to food or anything, so that is the plenty of resources and this is the limited resources. Here it's population and it's time, okay, population, time. Now at any particular time it can suppose this much number of population, suppose let it be 100, okay, let it be lakhs or whatever. So a particular land can support this much of population at any time, here also. So when there is limited resources, what we see that with the increase in time, slowly this graph grows and it goes like here. Okay, it goes parallel with the carrying capacity. So this is your this is slow growth, this is fast, and here it is becoming stationary. So we can see S-shaped graph, or it is also known as log type of graph. So slow, fast, and stationary. Now when there is plenty of resources, so with time this population growth will take slowly, but because there is no limitation on food or land, so what will happen, they'll grow exponentially. You can see they are growing exponentially. So this is a J-shaped graph and it is exponential growth. Okay, but after some time, you know, means after very long time, what will happen, resources will be it will come as a limiting factor at any point. Okay, suppose at this point the resource gets like over, so it will again drop down. Okay, this population is again dropping down and it is going in a negative way. So this is known as what? Outgrowth. Population outgrowth. Population outgrowth. And this is the carrying capacity. Now see, it had the potential to support this much of population, but this population grew up to here. So this is known as, this much of population which is above the carrying capacity is known as population outgrowth. So when there is plenty of resources, J-shaped exponential curve. When there is limited resources, there is S-shaped and logistic curve. Okay, so this was all about your carrying capacity, right? Okay. Yes, now come to the next one, that is the population interaction. Population interaction. Now in population interaction, that how in a particular group of species, how they interact among themselves. Like suppose there is a species A and there is a species B. So how they interact among themselves. So if both of them are beneficial to each other, then it is known as mutualism. Okay, now and these all are the types of symbiosis. Now what is symbiosis? Let me explain here. Whenever two species are living together, this is known as symbiotic relationship. So when two species, or more than that also, but generally two, when two species are living together, so that type of relationship is known as symbiotic relationship. Okay, so it is a type of symbiotic relationship, mutualism. Then we have predation, parasitism. Then we have competition. Next we have commensalism and amensalism. Okay, now when I say mutualism, then both of them are mutually benefiting each other. Okay, for example, let's take the example of leguminous plant. So the rhizobium bacteria, which is present in the roots of leguminous plant, it is also benefiting because it is fixing the nitrogen, and in return what that bacteria is getting is the nutrition from the plant. Okay, so positive is the mutualism. Predation, one is in the beneficial side and other in the नेगेटिव साइड. ओके, एक को प्रॉफिट हो रहा है, एक को लॉस हो रहा है. पैरासाइटिज्म अगेन पॉजिटिव फॉर द पैरासाइट्स एंड नेगेटिव फॉर द होस्ट. देन कंपटीशन, दोनों ही नेगेटिव रहते हैं. ओके, बोथ ऑफ देम आर इन अ नेगेटिव एंड, लाइक दोनों को ही लॉस हो रहा है. देन वी हैव कॉमेंसालिज्म, दैट इज वन is getting benefited from the other, but the other is neutral. Neither that particular species is getting benefited or is on the negative side. And then we have amensalism. One is getting one is like that particular species is in loss, and the another one is neutral. मतलब ना पॉजिटिव ना नेगेटिव, मतलब कोई प्रॉफिट नहीं हो रहा है, कोई लॉस नहीं हो रहा है. इट्स इन द न्यूट्रल स्टेज. क्लियर? पॉजिटिव म्यूचुअलिज्म, पॉजिटिव नेगेटिव प्रिडेशन एंड पैरासाइटिज्म. competition, both are losing. Then commensalism, one positive and another one is neutral. Amensalism, one is at the negative end and the next the other one is again neutral. Okay, now next we have is the ecological footprint. So ecological footprint was asked in GATE 2008 and in UPSC also. Ecological footprint. GATE 2008 and in UPSC 2016. Now, what is ecological footprint? Suppose, suppose there is any human being. So, how much resource that particular individual is using and how much there is waste generation. So, how much resource is being used and in the same way how much waste is generated, and if we see for the nature that how that waste is degraded by the nature. Now, for a particular individual, as I said, how much resource is being used by that particular individual and how much waste is generated by him. But for the nature, if we see that what is the ecological footprint for a particular nature or any ecosystem, then how that nature is degrading that the waste which was generated by a group of people, and how that nature is generating new resources. So if a nature is generating new resources at a very fast rate and on the other hand it is degrading waste also, so it means it is a growing in nature and it has good footprint. But if it fails to do so, then that nature is not in a growing state and it is it is not stable. Okay, so this was all about your ecological footprint, and yeah, it is measured in terms of global hectares. So it is measured in terms of global hectare. Clear? Yeah. Now come to the next one, that is the biocapacity. So biocapacity, it was asked in GATE again in 2008. So it is basically the estimation of nature, that how much resources it is able to produce. Okay, so bio means nature, means all the, from here we are taking the term nature, and capacity, how much is its ability to produce the natural resources. Okay, so it is the estimation of production of biological resources. Clear? Yeah. So it is the estimation of production of biological resources. So this is known as biocapacity. Clear? Okay, now let's come to the next one, that is the sustainable development. Sustainable development. Okay. Now, what is sustainable development? That is the development which meets the need of present generation without compromising the need of future generation. Okay. So, we are using the natural resources. So what is sustainable development? That we are that the use of natural resources should be in a way that it must meet the need of the present generation, and we have to keep in mind that that particular natural resource should be available for our future generation also. Okay, like coal, petroleum अभी तो यूज कर ले रहे हैं, बट वी शुड नॉट यूज इट दैट रिग्रेसली कि फ्यूचर जनरेशन के लिए वो बचे ही ना. ठीक है. सो इन ऑर्डर टू keep it available for the future generation also, we have certain sustainable development goals. Okay, sustainable development goals. Okay, which is also known as Agenda 2030. Agenda 2030. Now it has 17 goals. Under this, there is 17 goals to be accomplished with 169 targets. Clear? Yeah. Now see, this comes in match the following, that sustainable development goal or SDG is related to Agenda 2030. Now it was asked in like GATE 2017, 2009, in LMRC also. ठीक है, तो बस इतना ही इसमें इम्पॉर्टेंट है, दैट सस्टेनेबल डेवलपमेंट गोल्स Agenda 2030 is better known as Agenda 2030. It has 17 goals and 169 targets. That's it. Yeah. Okay. Now come to the next one, that is the Environmental Impact Assessment, that is EIA, and it has been asked like in GATE 2010 LMRC KCT that what is the full form of EIA. So it's Environmental Impact Assessment. Now when I say assessment, then assessment is like judging on its positive and negative impacts. So it comes under Environment Protection Act. Environment Protection Act. And when does this Environment Protection Act came in force? It was in 1986. Okay? Now, so it was established under Environment Protection Act in 1986. Now, UNEP, that is United Nations Environment Program, it defines EIA as a tool. Okay, it is a tool to identify the environmental, social and economic impact of a particular project on environment. That how a project is going to affect our environment in terms of the environmental aspect, like if it's creating too much of pollution or not, or is it good for our surrounding atmosphere or not. Then the social also and economic aspect also. So this is a tool to identify the impact of a particular project on environment. So if we see the duration of EIA, okay, now EIA, it's like a clearance certificate that if a project is good for our environment, then it will get the EIA clearance certificate, and if not, then that project will be will be stopped or will be hold for some time. Now see duration, like if it goes for all season, like these type of projects goes whenever there is screening of the impacts, so it goes for 2 to 3 season. If it's going for all season, like 3 seasons, like summer, winter, monsoon, then it is known as comprehensive EIA. Okay, and when it is that the duration of inspection is only for 1 season, then it is rapid EIA. Okay, now how this EIA project or report is made, is made. So it is made in 8 steps. So first one is the screening. Okay, now what we see in screening, that whether any particular project requires EIA or not. Okay, so that is the screening. Next we have scoping, that what are the impacts, like what will be the impact of any project on our environment. Okay, impact of project, or whether and in screening whether EIA is required or not. Then if it's required, then we will go to the next step, that is the scoping, and in scoping we see the impact of project. Okay, after scoping comes the third one, that is the impact analysis. Impact analysis, with the term itself you can understand that how bad or how worse it can affect our environment. So that impact is analyzed in the third step. Now the fourth one is the mitigation. Mitigation means what are the action one take to minimize those impacts. Action taken to minimize the impacts. Clear? Now, after mitigation, then reporting will be done. What is reporting? Like a detailed report will be made. Okay. So detailed report. Now after reporting, what will be the next step? That is the review. Review of what? Review of the report which was made based on the project. So the review of the report will be done in the next step. After review, there will be the decision making. I'm writing it here. Seventh one is the decision making. Okay. Now, in this decision making, the EIA office, the EIA related officers, they will see that whether they have to give the clearance for constructing those project or not. Okay, so they will give their approval or they will reject the project. Okay, now if approval is given, then in the last step, post monitoring, that in this step what will happen, that the project will start to be constructed in that particular area, and after that the environmental officers, they will come and they will monitor that whether all the guidelines are being followed or not, or all the laws and everything is being followed or not. Okay, so that is the post monitoring. So EIA, its full form, those 8 steps. Then if it is analyzed for all the 3 seasons, then it is known as comprehensive EIA, and if it is analyzed for 1 season, then it is rapid EIA. And yeah, it comes under Environment Protection Act. Yeah, this is all about EIA.